right, quick review on polyhedron, which is solid, three-dimensional solids like we've been studying. They're formed by 4 or more polygons that intersect only at their edges. Okay, so like if you look at this pyramid here, it's a pentagon and 5 triangles, and they only intersect at their edges, right? Or here, this is a rectangle and two circles. They only intersect at their edges. You can tell that that something is a polyhedron because it will fit Euler's formula. And the formula is that if you take the number of vertices minus the number of edges plus the number of faces, it should equal 2. Okay, so if we look at this pentagon, or this pentagonal prism, sorry, if you look at the vertices, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 vertices. There's 1, 2, 3, 4, 5, 6. No, there should be 5 around the, I think I counted a top here. So there's 5 edges. 1, 2, 3, 4, 5, and then 5 around the front and the back. So there's 5 around the sides, and then there's 1, 2, 3, 4, 5 in the front, and 1, 2, 3, 4, 5 in the back. So that's 15. So there's 15 edges. And then faces, there's 1 in the front, 1 in the back, and then 5 around the sides. And you can always see that by drawing in the net of the shape. There's a pentagon shape here, and 1 here, and then there's 5 edges. So there's 5, 6, 7 faces. And I plug it into Euler's formula. 10 minus 15 plus 7, that's negative 5 plus 7 is 2, so it checks. So it would be a polyhedron, okay? All right, so that's kind of straightforward. Like on a test, I just say verify this is the polyhedra using Euler's formula, and you just plug in the vertices, the edges, and the faces. Calculate, make sure it comes to 2. All right, then because we're talking about three-dimensional figures, we need to learn to graph in 3 dimensions, okay? Up till now, we've always graphed in 2 dimensions, like you have this XY axis. So if I wanted to graph like 2, 3, I would go over 2, up 3, and there'd be my point. And if I did that 4 times, I could make like a square, okay? Now, in 3 dimensions, they've taken this XY axis and turned it flat. So instead of looking at it like, basically we've always looked at the XY axis like we're looking down on it from the top. Now we're going to look at it kind of from the side. We're going to add the dimension of height. Okay, so here's my XY axis. Okay, so basically I took this X and this Y here, so this X, this Y, and you're kind of looking at it from the side, and you're putting Z in, going up and down. Okay, so this may take a little bit of time to kind of look at it. Another way of looking at it, graphing wise, is this is a very common 3-dimensional graph. You see how we have X, Y, and Z. Hold on, let me, I don't think it's all going to fit. So here's X. This is the X-axis, Y-axis. So those would be, if you were looking down on it from the top, the Y would be going, this is the positive, and then back here would be the negative, and here would be the positive, and this would be the negative. So, and then this Z here is going up and down. So if you went underneath the graph, that's when you get that negative. Okay? All right. So if I were going to graph, for instance, now, because we're graphing in 3 dimensions, I need 3 coordinates. My ordered pairs are now going to have 3. It's still an ordered pair, so X comes first, Y comes second, Z is third, or alphabetical order. So along the X-axis, I'm going to go 3. So 1, 2, 3, sends me down to here. For the Y-axis, I'm going to go 2, so over 1, 2. And then for Z, I'm going to go up 4. Now this takes a little bit of sort of visualizing. We're going to go up 4, but remember, we're looking at it tilted. So really going up 4 means from here, we're going up 4. So 1, 2, 1, 2, 3, 4. So my dot is going to be right there. Okay? All right. So for instance, another one may be 1, 3, 1. X comes first, so I'm going to go 1 on the x-axis, 3 on the y-axis, 1, 2, 3, and then up 1. So I'm going to go up to here, kind of go over from there. So my my dot is floating in space right there. Okay? Take a second and try to graph these other two, 4, 4, 4, and 0, 2, 6. Okay, so 4, 4, 4 would be 1, 2, 3, 4 to here, and then 1, 2, 3, 4 to here, and then up 4, I would look over here, 1, 2, 3, 4, and just kind of draw this dotted line over and go up, and so my 4, 4 point would be right there, floating in space. All right, and 0, 2, 6 means I go 0 down the x-axis, 2 on the y, and then up 6. So that's up at the top here. All right, that's going to take a little bit of practice. So on your homework tomorrow in class, we're going to have a little bit of that to do. And then if I were going to graph like a rectangle or a prism, all right, let me get all this stuff out of here. I'm going to graph a prism. Let's say it's got dimensions of 3 by 2 by 2. That means it's going to be 3 long, so it's, and then 2 wide. So I'm going to go down 3 to here. It's going to be 2 wide to here. This side is also going to be 3 long, and this side is going to be 2. So this is my base. Can everybody see that? All right, and then it's going to be 2 tall. Okay, so remember it's a 3 by 2 base and with a 2 height. Okay, so 3 down, 2 over, 3 and 2. Okay, and then it's going to be 2 tall. So I go up 2 to here. Each one is going to go up 2. 1, 2, so we'll be about there. So the top would look like that. And then can you see the connectors here, 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 and there? And that would be a rectangle. Okay. Again, we're going to practice this. Then the other thing in 3 dimensions that we talk about is finding the diagonal of a prism in 3 dimensions. And basically, it's setting up 2 right triangles. The first one you do is good old 2 dimensions. So you use the base, and you say, okay, here's the 2 legs of my right triangle, and here's the hypotenuse. And if I know the length and the width, I can find this diagonal. Then I'm going to use that diagonal to make another right triangle here to here to here. And this time, these 2 become the legs, and this one is the hypotenuse. Okay, so let's try one of those. All right, so we're going to try to find D. So I'm going to set up my first right triangle here. So 3 squared plus 5 squared equals C squared. So that's 9 and 25, which is 34. So C squared is 34. Okay, so C is square root of 34. Then, I'm going to do another right triangle down here, here, and here. Okay? It's 4 tall, so one of my legs is going to be 4. The other leg is going to be square root of 34, and then the D is what I'm finding. So to find D, I'm going to do 4 squared plus square root of 34 squared equals C squared, or D, in this case, D squared. Okay? So that's 16 plus, and square root of 34 squared, those cancel each other out, so I just get 34 equals D squared. So that's 40, 50. So D squared is 50. So D is square root of 50, which is 5 square root of 2. Right? It's 25 times 2. All right, so that's how you find the diagonal. Okay? Now, the other calculations we've been doing all along with 2-dimensional polygons, like the distance formula and the midpoint formula, don't change. They're still the same, but now we have to add that 3rd dimension. So the distance formula is going to be, instead of x1 minus x2 squared plus y1 minus y2 squared, which is where we normally stop, now we're going to add z1 minus z2 squared. So the whole thing will give me the distance of the distance of a segment that's going out into space. All right? And midpoint, same thing. Instead of just doing x1 plus x2 over 2, y1 plus y2 over 2, now we're going to add z1 plus z2 over 2. So take a second and calculate this distance and midpoint, and we can check your answers. Okay, so we do x1 minus x2, so 0 minus 3 squared plus 0 minus 4 squared plus 0 minus 5 squared. So we got negative 3 squared is 9, negative 4 squared is 16, and negative 5 squared is 25. So I get 25 plus 25 is 50, square root of 50, which again is 5 square root of 2. We just did that. So the length of a segment that goes from 0, 0, 0 to 3, 4, 5. So if you think about it, here's x, here's y, there's z. 3, 4, 5 would be 1, 2, 3, 1, 2, 3, 4, and then 1, 2, 3, 4, 5, one down this way, so up 1, 2, 3, 4, 5. So it would be about there. So the distance, so that, can you kind of see this segment going off into space like that? All right. And then the midpoint of that shape would be 0 plus 3 over 2, 0 plus 4 over 2, and 0 plus 5 over 2. So the midpoint of that segment would be 1.5, 2, 2.5. All right? And so that's it for three-dimensional drawing. I know it's going to take some practice, so don't panic, but we just got to roll up our sleeves just like cubes. But what I'd like you to do now on a separate sheet of paper to turn in tomorrow, can you please answer these 3 questions? Sketch a hexagon, an equilateral triangle, and then a plane that intersects 4 faces that only 2 parallel sides. Then identify that a figure that's represented by these 2 nets individually, and then draw the net of a cylinder. All right? Good luck.